Welcome to the year 1000 BCE. Put down your smartphone for a second, because we need to talk about where your time actually comes from. You think in base 10 because you have 10 fingers. But the Babylonians? They chose 60. And it changed the universe forever. Why 60? Because it's a supercomposite number. It divides by 2, 3, 4, 5, 6, 10, 12. It is the perfect math for a circle. They divided the sky into 360 degrees because it was close to the 365 days of a year. Geometry and time became one. And that's why your hour has 60 minutes. You are literally living inside an ancient Babylonian algorithm right now. But they weren't just counting. They were cataloging. This is the MUL.APIN, the world's first comprehensive star library. Written around 1000 BCE, these tablets listed 66 constellations and their rising dates with scientific precision. They realized the planets weren't just random lights. They called them wild sheep because they wandered across the fixed stars. Jupiter was their favorite. They tracked it so accurately they used geometry that wouldn't appear in Europe for 14 centuries. How did they do it without telescopes? Pure, brutal, beautiful data collection. Every night. For centuries. They were the first to find the Saros cycle, a pattern of 18 years that predicts exactly when an eclipse will happen. To the king, this was magic. To the scribes, it was math. They turned the chaos of the gods into a predictable machine. They also gave us the 12 signs of the zodiac. Not for horoscopes, but as 30-degree markers to map the sun's path. So next time you're checking your star sign, remember, you're actually using an ancient Mesopotamian coordinate system. Before the Greeks, before the Romans, the Babylonians had already written the first chapters of the universe. And we're still reading them. But how did they track those wild sheep across the void without computers or telescopes? They had a secret weapon, arithmetic. Every single night for nearly 700 years, priests recorded the position of the moon and planets in what we call astronomical diaries. They used normal stars as cosmic mile markers. Jupiter is 3 cubits below the star Alpha Leonis, they would write. They didn't see gravity, they saw systema, a mathematical zigzag that predicted when a planet would speed up or reverse. This was the birth of mathematical astronomy. No physics, no orbits, just pure, beautiful numerical sequences. They predicted eclipses by calculating the exact intersection of the moon's tilted path and the path of the sun. By the 4th century BCE, their accuracy was so high they could predict a lunar eclipse months before it happened. They even mastered retrograde motion, when planets seemed to move backward, using nothing but addition and subtraction. This wasn't just religion. This was the first time humanity realized the universe followed rigid, repeating laws. The universe was no longer a chaotic mess of gods, it was a solvable equation written in stone. Meet the Tupsar Enuma Anu Enlil, the scribes of the celestial omens. These were the world's first data scientists. They developed competing theories. System A used step functions, System B used continuous linear slopes. Just like modern science. They didn't need to know why the planets moved. They just needed to know when. And they were almost never wrong. By calculating the great year, when all planets returned to the same spot, they touched the eternal rhythm of the cosmos. But this was just the beginning. Next, these clay secrets would travel west, to a place called Greece. And things were about to get geometric. As empires rose and fell, Babylonian data didn't just sit in libraries, it traveled. It followed the trade routes west, toward the sea. In the markets of Athens and Ionia, these clay numbers met a new obsession, Greek geometry. The raw data found a new home. This was a cosmic fusion. The Babylonians were masters of arithmetic, the Greeks were masters of the shape. Meet Hipparchus of Nicaea. He is often called the father of trigonometry, but his secret was a 600-year-old library. Using Babylonian eclipse records, he calculated the distance to the moon with shocking accuracy for his time. He realized the data from the east was the key. He took the 360-degree Babylonian circle and made it the standard for Greece. The universe was no longer just a list of numbers, it was a physical sphere that could be mapped and measured. From the top of a ziggurat in Babylon to the cliffs of Rhodes, the language of the stars remained the same. Babylon provided the when, the timing. Greece provided the how, the shape. Together, they gave us the first model of the cosmos. Without those clay tablets, the Greeks would have been guessing in the dark. We owe our coordinates to the scribes of Mesopotamia. Hipparchus even discovered precession, the slow wobble of the Earth's axis, by comparing his data to records from 150 years earlier. He was looking at the exact same stars the Babylonian priests had watched for centuries. Science was becoming a global conversation. This data didn't just stop in Greece. It spread to Alexandria, to Rome, and eventually to every smartphone on Earth today. We built our modern world on a bridge of clay and marble. A bridge that connected the math of the East to the logic of the West. Act 1, the calculators of fate, is complete. But the universe was about to get much, much bigger. Prepare for the revolution. For 1500 years, the world lived inside a beautiful, logical, but completely wrong lie, the geocentric model. Meet Claudius Ptolemy. In 150 CE, he wrote the Almagest, the book that would lock Earth at the center of the universe. He used the same Babylonian data we saw before, but he twisted it to fit a world that didn't move beneath his feet. But there was a problem. The planets didn't actually move in perfect circles. They wandered. They paused. They danced. To fix it, Ptolemy invented epicycles, circles within circles. It was the most complex hack in scientific history. By the time he was done, the universe looked like a cosmic spirograph. It worked, but it was ugly. Then came 1543. In a cold tower in Poland, a man named Nicholas Copernicus looked at those same ancient tables. He realized that if you just put the sun in the middle, all those messy circles simply vanished. The math became infinitely simpler. We weren't the center of a spirograph, we were just another wild sheep circling a star. Earth was no longer the throne of the universe. It was just a traveler in the dark. And people were terrified. This is Occam's razor in action. The simplest explanation is usually the correct one. But simple doesn't mean easy. Copernicus was so scared of the backlash that he only allowed his book to be published on his deathbed. Legend says he received the first printed copy just hours before he died. He had set the world in motion. But a model is just a drawing. To prove it, we needed eyes. We needed someone to point a piece of glass at the dark. Enter Galileo Galilei. The man who saw things that weren't supposed to exist. In 1609, Galileo Galilei didn't invent the telescope, but he was the first to turn it toward the heavens with the mind of a scientist. What he saw shattered the old world. He found that the moon wasn't a perfect, smooth orb, it had mountains and craters. If the moon was imperfect rock, just like Earth, then Earth wasn't special. It was just another world. Then he found the smoking gun. For tiny moons dancing around Jupiter, Io, Europa, Ganymede, and Callisto. This proved that not everything in the universe revolved around the Earth. Ptolemy's geocentric model was bleeding data. But his most damning proof was Venus. He observed that it went through phases, just like our moon. This was mathematically impossible if Venus circled the Earth. It could only happen if Venus orbited the Sun. Galileo wasn't just looking at stars, he was looking at the death of an old dogma. And he knew the risks. He published his findings in 1610. The Starry Messenger. It was a bestseller, and a death warrant. In 1633, the Inquisition came. They didn't care about his math. They cared about their power over the truth. Forced to kneel and recant his life's work, he was sentenced to house arrest for the rest of his days. Legend has it, as he rose from his knees, he whispered, "E puris I move." And yet, it moves. Because the universe doesn't care about our dogmas. It just keeps on spinning. Galileo proved that observation is the only true source of knowledge. But to truly understand the how, we needed something more. We needed the man who would turn the universe into a machine. Enter Isaac Newton. In 1666, while the plague ravaged London, young Isaac Newton sat in a quiet garden, watching an apple fall. He didn't just see fruit, he saw a connection that spanned the entire cosmos. A force he called gravity. He realized the same power that pulled the apple was the same power holding the moon in its orbit. By 1687, he published his Principia Mathematica, the book that turned the universe into a solvable machine. He defined it with the inverse square law. Double the distance, and the pull of gravity drops to 1/4. Newton stood on the shoulders of giants. He took the data of Babylon and the geometry of Greece to build our world. The universe was no longer a mystery of the gods. It was a predictable, mechanical clockwork governed by law. But there was one tiny problem. Newton's gravity worked perfectly, but he had no idea how it actually worked. He called it action at a distance. A spooky pull across the void with no visible connection. It haunted him. For 200 years, we just accepted the math. But the secret of the pull was hidden in the fabric of the universe itself. Newton's laws were so perfect they allowed us to predict the existence of new planets before we ever saw them. The scribes of Babylon would have been proud. Their base, 60 math was now the foundation of a galactic order. But the clockwork universe was about to be broken. By a clerk in a patent office who had a different idea about time. Newton's space was a stage. But for Einstein, the stage itself was alive. Get ready. We're about to break the speed of light. Act 2, the heliocentric revolution is complete. In 1905, a simple patent clerk in Bern named Albert Einstein changed everything. He realized space and time were not separate. He saw them woven together into a single, invisible fabric that blankets the entire universe, spacetime. He discovered the ultimate speed limit, light. Exactly 299,792,458 meters per second. Nothing can go faster. In 1915, he realized gravity isn't a pull. It's the curvature of spacetime itself. Like a bowling ball on a trampoline. Earth doesn't fall because of an invisible string, it's simply following the shortest path through a curved world. Einstein used the same 360-degree geometry of the ancients, but he added a fourth dimension, time. This meant gravity could even bend light. In 1919, an eclipse proved him right. The universe was dynamic. But Einstein's equations showed something even more shocking. The entire universe was either expanding or contracting. Einstein hated this. He even invented a cosmological constant just to keep the universe still. He was wrong. In 1929, Edwin Hubble used the world's largest telescope to prove the expansion was real. The universe had a beginning. If it's expanding now, it must have been smaller yesterday. And 13.8 billion years ago, it was a single point. The Big Bang. Not an explosion in space, but an explosion of space. Spacetime itself was born. We can still see the echo of that birth today. The cosmic microwave background, the oldest light in the universe. The Babylonians mapped the stars to find their fate. Einstein mapped spacetime to find the truth. But as we looked closer, we found that the smooth fabric of spacetime was hiding a chaotic secret. The quantum world. Welcome to the Planck scale. This is the smallest possible distance in the universe. $1.6 times $10 to the negative $35 meters. At this scale, Einstein's smooth fabric of spacetime dissolves into a violent, bubbling, quantum foam. Here, an electron doesn't have a fixed home. It exists in superposition, being everywhere and nowhere at once. This is the world of Werner Heisenberg and Niels Bohr. They found that at the heart of reality, there is only probability. Heisenberg's uncertainty principle: you can know where a particle is, or how fast it's going, but never both. The moment we observe them, the cloud collapses. Reality picks a side. The act of looking creates the world. Then there is entanglement, what Einstein called spooky action at a distance. Two particles linked across the cosmos. Tickle one, and the other reacts instantly. No signals, no delay, faster than the speed of light. Einstein hated this. He famously said, "God does not play dice with the universe." He thought quantum theory was incomplete. But here is the problem: the universe at its smallest level ignores the laws of the universe at its largest. They don't speak the Kung language. We need a bridge. A theory of everything. A single master equation to unite the stars and the atoms. This bridge is hidden in the most extreme places. Like the center of a black hole, where gravity and quantum meet. Here, the infinite pull of gravity crushes matter down to a quantum point. The math breaks. And we are left with a mystery. The search for this equation is the final frontier of the human mind. From clay tablets to quantum computers. We are now using the most powerful eyes ever built to find the answers. Phase 8, the quantum puzzle is complete. On Christmas Day, 2021, we launched the most complex machine ever built, the James Webb Space Telescope. It traveled 1.5 million kilometers to reach L2, a stable point where it stays cold enough to see the invisible. Hubble saw visible light. Webb sees in infrared, peering through cosmic dust to find where stars are born. We are seeing galaxies from 13.5 billion years ago, the first light after the dark ages of the Big Bang. But Webb found something strange. Some early galaxies are too big, too soon. They are breaking our old models. While Webb looks for light, LIGO listens for ripples. This is how we find the invisible side of the universe. In 2015, we detected gravitational waves from two black holes colliding 1.3 billion light-years away. We aren't just looking anymore, we are listening to the heartbeat of the cosmos. Einstein was right, again. But the biggest mystery remains: everything we can see, stars, planets, us, makes up only 5% of the universe. The rest is dark matter and dark energy, mysterious forces that hold galaxies together and push space apart. Dark energy is the ghost in the machine, causing the universe to expand faster and faster toward an uncertain end. From the clay tablets of Babylon to the infrared eyes of Webb, we are still just scribes trying to read the sky. In 2019, we turned our entire planet into a telescope to see the shadow of a black hole for the first time. What was once a mathematical curiosity in a trench is now a photograph. The unseeable has been seen. But where does it all lead? Our journey ends at the ultimate destination, the end of everything. Phase 9 is complete. As we look billions of years into the future, the very stars that guided the Babylonians will eventually begin to fade. The expansion driven by dark energy will push galaxies so far apart that the night sky will eventually become a total, lonely void. Even the black holes will evaporate through Hawking radiation, leaving nothing but a bath of cold, lonely photons. It sounds terrifying, a universe that begins in a brilliant flash and ends in a cold, dark whisper. But there is a deeper perspective. The atoms in your body were forged in the hearts of stars that exploded billions of years ago. As Carl Sagan famously said, we are a way for the cosmos to know itself. We started as priests on Ziggurats using clay to track the moon, and we have grown into a species that can hear the ripples of spacetime. We are the bridge between the ancient math of the past and the infinite mysteries of the future. The library of the sky isn't written in clay anymore, it's written in our curiosity. And the story has only just begun. As long as we keep looking up, the story of the universe will never truly end.